So let's take a look at how we can use logarithms to figure out how quickly money will double if it's invested at an annual rate of 5% compounded continuously. So here, our annual rate is 0.05. Our initial amount, so P is the initial value. I don't know what it is, but it doesn't really matter. P is just some initial. It might be $100, $1,000, doesn't really matter. And we would like our final to be 2P. This is what we would like our final amount to be, or our future value. So we can use our continuously compounding formula. So we have that 2P, so our future value is equal to our current value, P, or our current investment, what we're investing now, e to the RT, where T is how long it's going to take for our original P to eventually get to 2P. So here we have the P's cancel out, which is why that we don't really care what P is. P is just, it can be anything that you want. It's not really that important. So now we have an equation that looks like 2 e to the 0.05t. And now if we want to figure out what t is the thing we're trying to solve for, and it's an exponent, so it would be good if we dragged that out of the exponent. So what we're going to do is we're going to take the log of both sides. What log should we use? Well, we should use the log that is base e, which is the natural logarithm. So this becomes ln 2. If I take the natural logarithm of both sides, this becomes ln 2 of, and then on the right hand side we have ln 0.05t. And the natural log of e to the 0.05t, this comes down, and this becomes 0.05t times the natural logarithm of e, and this is just 1. So this becomes 0.05t. And so if we rearrange this and solve for t, we find that t is equal to ln 2 divided by 0.05 years. And that's a totally fine answer. We don't need to go to any decimal places for that if we don't want to.